Welcome back to our class for our semi-final week or module number 6. So our topic is about Kirchhoff's law. So Kirchhoff's circuit laws allow us to solve complex circuit problems by defining a set of basic network laws and theorems for the voltages and currents around a circuit. However, sometimes in complex circuits, such as bridge or T networks, we cannot use Ohm's laws alone. So to find the voltages or currents circulating within the circuit. For these types of calculation, we need certain rules which allow us to obtain the circuit equation. And for this, we can use Kirchhoff's circuit law. So, unsa man yung Kirchhoff's circuit law? So, in 1845, a German physicist, Gustav Kirchhoff, developed a pair of set of rules or laws which deal with the conservation of current and energy within electrical circuit. These two rules are commonly known as Kirchhoff's circuit laws, with one of Kirchhoff's laws dealing with the current flowing around a closed circuit, which is Kirchhoff's current law or KCL, while the other law deals with the voltage sources present in a closed circuit, which is Kirchhoff's voltage law or KVL. So sa Kirchhoff's law di ay natay duha ka buok nga rules, which is ang KCL and KVL. So first, we need to tackle about the first law, which is the current law or the KCL. So unsa man ning KCL? So Kirchhoff's current law or KCL states that the total current or charge entering a junction or node is exactly equal to the charge leaving the node as it has no other place to go except to leave, as no charge is lost within the node. So, ang KCL di ay mo ni ang total current or current nga entering is also equal to current leaving. So, we have here our figure for our currents. So, currents entering equals current leaving in the node. So, if ever natay value nga I1 plus I2 plus I3, so, sila, kanang tulo ka buok, entering na siya na current. While ang I4 and I5 is leaving. So, therefore, equal ra siya. So, next, we have the three currents enteren. So, giingon ganina, di ba? Ang naay tulo ka current na nag-enter. So, I1, I2, and I3 are all positive in value. And the two current leaving the node, I4 and I5, are negative value. So, this means, so we have our equation na na-derive. So, I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. So, giingon nga na ay node. So, unsa maning node? So, the term node in electrical circuit generally refers to a connection or junction of two or more current carrying paths or elements such as cables and components. So, ang node di ay mo ni siya ang connection or junction na more than two nga naay current na nag-agi or nag-flow sa atoang circuit. So, kabalo na to for our Kirchhoff's first law, which is the KCL. So, unsa to ang summary ani is current entering the node is equal to current leaving the node. So next, we need to tackle for the Kirchhoff's second law or the voltage law or KVL. So KVL states that in any closed loop network, the total voltage around the loop is equal to the sum all the voltage drops within the same loop. So, ang KVL, so ang giingon, na siya'y closed loop network. So unsa man ning closed loop network? So kanang nara siya sa isa ka buok nga travel ang voltage. So equal siya sa sum of all the voltage drops. So we have our conservation. So in other words, the algebraic sum of all voltages within the loop must be equal to 0. So this idea by Kirchhoff is known as the conservation of energy. O ang KVLDI gitawag po siya og conservation of energy. So we have here our figure. So in Kirchhoff's voltage law, so giingon nga the sum of all the voltage drops around the loop is equal to 0. So we have here our example. So in VAB, so kaning A to B plus B to C and C to D and VDA is equal na siya to 0. So starting sa atong figure, starting at any point in the loop, continue in the same direction. So either positive or negative and returning back to the same starting point. So take note that it is important to maintain the same direction, either clockwise or anti-clockwise, or the final voltage sum will not be equal to 0. So dapat sa Kirchhoff's voltage law, so dapat if mag-solve ta, dapat isara ato ang direction nga i-follow. So when analyzing either DC circuits or AC circuits, using Kirchhoff's circuit law, a number of definition and terminologies are used to describe the parts. So kaning magamit ani, so naatay mga terms and we need to understand them. So here are the common DC circuit theory terms. So sa electrical, so mostly mo ni sila ang mga gigamit nga terms for a circuit. So first, we have circuit. So unsa man ning circuit? A circuit is a closed loop conducting path in which an electrical current flow. And second, we have path, a single line of connecting elements or sources. And number 3, node. So giingon na nato ni ganina. So junction siya, connection or terminal within a circuit where two or more circuit elements are connected or joined together, giving a connection point between two or more branches. So a node is indicated by a dot. So number 4, we have branch. So saan yung branch? A branch is a single or group of components such as a resistor or a source which are connected between two nodes. And number 5, we have loop. A loop is a simple closed path in a circuit in which no circuit element or node is encountered more than once. And lastly, we have mesh. So a mesh is a single closed loop series path that does not contain any other path. So there are no loops inside a mesh. So take note that components are said to be connected together in series if the same current value flows through all the components. So components are said to be connected together in parallel if they have the same voltage applied across them. So now we all know the terms and the two rules in Kirchhoff's. So let's apply it in our first example. So we have here, find the current flowing in the 4 ohms resistor or R3. So natay given nga circuit. So in our circuit, we have our voltage which is 10 volts, then R1 10 ohms. So we need to write our given. We have our R1 10 ohms, R2 is 20 ohms, and R3 is 40 ohms. And naatay I1, I2, and I3. So the circuit has three branches, two nodes. So ang nodes, di ba, naka-indicated siya as dot. So we have here sa itong circuit, two nodes A and B, and two independent loops, which is loops number 1 and loop number 2. So napuntay given nga duha ka voltage, V1 which is 10 volt and V2 is 20. So magamit na nato ang KCL sa ato ang equation. So at node A, we have our equation I1 plus I2 is equal to I3. And for our node B, I3 is equal to I1 plus I2. So using Kirchhoff's voltage law or KVL, the equation are given as, so we have 10 is equal to R1 multiplied to R1, I1 plus I3 multiplied to R3. So 10 ang atong R1 plus 40 ang atong R3, and loop 2 we have 20 I2 plus 40 I3, and loop 3 we have 10 minus 20 is equal to 10 I1 minus 20 I2. So as I3 is the sum of I1 and I2, we can rewrite the equation as, so kaning equation nato dire, so pwede nato siya ma-rewrite as, we have here 10 I1 plus 40 I1 plus I2, and 20 I2 plus 40 I1 plus I2. So we have our equation number 1 and equation number 2. So we now have two simultaneous equations that can be reduced to give us the values of I1 and I2. So substitution of I1 in terms of I2 give us the value of I1 as 0.143 amperes, and substitution of I2 of I1 give us the value of I2 as 0.429 ampere. So the current flowing in resistor R3 is given as, so I1 plus I2 is equal I3, so 0.143 plus 0.429 is equal to 0.286 amperes. So solving for the voltage across the resistor, ang unknown nato, so we have 0.286 times sa atoang R, which is 40. So our answer will be 11.44 volts. So that will be our final answer. So next, in our semifinal, we have Maxwell mesh method. So each independent loop in the circuit is assigned with a circulating current called mesh current. The KVL is applied to this loop to create algebraic equations to solve the mesh currents. So kaning Maxwell, so mostly nagamit siya og KVL iyang magamit sa equation. So first, our example, find the current in the resistor RL of the network as shown. So use Maxwell mesh method. So natay circuit, and we have our given, which is we have R1 and we have R2 and we have our voltage 1 and voltage 2, and our RL is 0.8 ohms. So assigned and assume direction of loops current. So nag-assign ta, we have our A, B, C, and D. So applying KVL on a loop ABDA, so we have here, so KVL na to, E1 minus IA. So kaning IA na to, we have R1 and RL. So minus sa ato ang IB, we have IB here. So sa tong IB naatay RL and IB. So is equal to 0. So to simplify, so atong I1 is 24, IA is 1.2, IA minus 0.8, and I multiply to IB is equal to 0. So after na to, ma-apply sa loop ABDA. So kaning dire ABDA. So kanira na siya ha. Kanin nga loop 1. So we need to apply pod in loop ACDA. So kani ACDA. So kanina loop dire sa ikaduha. So we have our E2 minus IB. And we have R2 and RL minus IA multiply to RL is equal to 0. So natay data, substitute. So natay equation which is two simultaneous equation. So kaning 24 og 26 sa ubos. So para mas madali na to og solve, pwede ta makagamit sa tong calcu. So use calculator mode 5.1 to solve IA and IB. So mas dali since pwede ta maka calculator technique. So giingon use calculator mode 5.1. So kaning 5 which is the equation and 1. So we have here, so sa ato equation 1 we have 1.2. And for the B, we have 0.8. And for our C, kane, which is 24. And for our second equation, so ang atong A is 0.8. And our B is 1.2. And our C is 26. So we have here our X is IA. For our IA is 10 ampere. And atong IB is 15 amperes. So dali ra siya since nakagamit ta og calculator technique para mas makuha na to dayon. So as shown, the current resistor RL is equal to the sum of the mesh current IA and IB. So therefore, our line current, so ibalik na to, 1. So 10 plus, so sum ra di ay 15. So our IL will be, our final answer here is 25 amperes. So take note ta sa atong calculator. So very easy ra to siya, no? So for our last topic, for our semifinal, we have here a node methods. So in this method, a solution is determining the currents flowing in a given network is possible with n-1 equations, where n represents the number of nodes in the circuit. So nodal node methods uses the KCL concept. So kaning nodal di ay, ang concept na to gigamit is KCL. So let's try for our example number 1. So find the current in the resistor RL of the network as shown. So using Nodal method. So natay R1, R2, our voltage 1 and voltage 2 and our RL. So note that the circuit has only two nodes. So therefore a solution is done by only one KCL equation. So asa man natong node ane? Kaning A and N. So diba in KCL at node A, so current entering is equal to current leaving. So I1 plus, so enter I1 plus I2 is equal to I3. So kaning IL dere. So therefore nata equation based atong KCL. So therefore, for I1, we have E1 minus VAN over R1 plus A2 minus VAN over R2 and is equal to kaning sa I3 sa V A2N we have over RL. Since given ang duha ka voltage, so ang I1 ug I2 which is 24 and 26. So to solve this equation na simplify nato which is kani equation, so note, use the solve function in the calculator to solve for VAN. So para dili na maglisod, pwede nato siya ma-solve directly using the solve function. So let's try in our calculator. So we have substitute 24 minus alpha for x for VAN na to. So variable x atong gigamit over 0.4 ang atong R1 plus 26 atong E2 alpha atong gamit variable x over R2 is 0.4 is equal, so alpha equal to VAN, so x over ang atong RL nga given is 0.8. To solve for our variable x or VAN, so we need to use solve function. So solve, shift, solve, pwede na to solve for x if 0. So our answer for VAN is, here we have 20 volts. Since ang gipangayo sa atong problem is the current, so since nanatay 20 volts sa ato ang VAN along A to N kaning dere, so pwede na nato ma-solve ang IL. So solving for IL, so IL is equal to VAN over RL. Since na-solve nato ang VAN which is 20, so 20 divided by 0.8 which is the RL. So our final answer will be 25 ampere. So atong load current is 25 ampere. So if you have any question or clarification, you can ask me in our Google Classroom. So be ready for our upcoming exam, and I hope na I na-learn today, and good luck and thank you.